Hello, everyone. My name is Ming-Shen Sun. I'm a research scientist at TikTok, driving applications and innovations of the trusted computing technologies at TikTok. Today, I'm going to present our recent innovative solution with trusted execution environment for auditable and verifiable transparency. In this talk, I will briefly introduce the importance of transparency and the motivation of a greater auditable and verifiable software transparency. Then, I will introduce the building blocks of this solution to achieve this goal. Lastly, I will discuss its potential applications in recent AI ML industry and how this solution can help us. Transparency is a key component to building trust with public users and regulators. In practice, for software transparency, open sourcing and third-party auditing are two main ways providing software transparency. TikTok have several transparency initiatives. You can check them out in TikTok Transparency Center and TikTok for Developers. We, along with many other companies, join this open sourcing community, providing better transparency to the public. You can check out our TikTok and TikTok privacy innovation organizations on GitHub. However, we can do better. One challenge with open sourcing the source code attracts my attention. That is, how to provide verifiable proof that this code or algorithm is in production. From the user's perspective, there's currently no way to tell if one repository is actually being used in production. There are many potential solutions the community has been discussing. For example, versioning the algorithm or code with a cryptographic hash displayed somewhere on the public and easy to find. The cryptographic hash is generated for each release and can be verified by a member of the public and that is in production. Verification does not need to be durable by any non-technical person, but instructions for verification should be provided. And it must be a credible and trustless process. Alternatively, but ideally, a trusted independent third party verifies a version of cryptographic hash, whatever it is claimed to be used, and outline how they did it. Okay, now if you're familiar with this kind of large-scale system, you may notice a lot of gaps, both in complexity perspective and security and integrity perspective. For example, there may be multiple versions and many different microservices deployed in production. How do you handle this solution? In security perspective, at runtime, how to prove the service provider deployed the correct algorithm? From user's perspective, how can you convince me the decision I get is made by the algorithm for review? Of course, this kind of solution is a very good starting point. Now we have talked a lot about the problem and the challenges. What's our solution? Before you introducing the technical details, let me start our ultimate goal here. In our solution, we want to achieve the next level of software transparency. That is, a service provider can present a third-party endorsed proof that the code for audit is currently deployed and used in production. And these claims can be verified by public individuals independently without trusting the service provider. There are two main challenges. Firstly, auditability. How to provide a trusted platform for third-party auditing. Secondly, verifiability. How to provide a verifiable proof to the public that the software for audit is actually deployed and used in production. In our solution, with trusted execution environment, we want to provide software transparency with both auditability and verifiability. In details, there are three building blocks. Firstly, trusted auditing, an environment for auditor to review the source code and the building environment. TE assures the integrity of building process is trusted. Auditors can endorse, that is, cryptographic sign, static reference measurements to the public after reviewing the source code and the corresponding artifacts. The auditing assertions may include integrity of the building pipeline, which is no suspicious codes are injected during the building process. Secondly, integrity of open sourcing process. Open source code and internal source codes are consistent except the minimal modifications for public disclosure, for example. Thirdly, integrity of the platform, which is optional. For example, the properties like no bias, the rules are consistent, so on and so forth. For the endorsements, that is a signed attestation report with reference measurements of the compiled artifacts, and a signed source code, a zip table with the open source code. Thirdly, which is also optional, the signed assessment report. Note that the code auditing process can be done for any update of the platform. Otherwise, public individuals will notice that the deployed measurements are different from the reference measurements. However, since auditing assertions are well defined, we can automate the process very easily. Secondly, remotely attestable platform. We can deploy services on the TE-enabled hardware with remote attestation provided by TE. It can generate hardware-signed runtime attestation report. Thirdly, independent verification. For public individuals, they can compare the endorsed reference measurements from the trusted auditors and the runtime measurements issued by the hardware platform. If the two measurements are consistent, this means that the code for audit is exactly the same as that deployed in production. With this process, we can establish an auditable and verifiable transparency of software in production for any parties. From our perspective, this kind of software transparency is important to build trust with everyone. Therefore, we are continuing driving these scenarios and glad to collaborate with the trusted computing community. So to summarize, the chain of trust to building trustworthiness is like this. For public individuals, they need to trust two kinds of identities. Firstly, third-party auditors, which could be auditing firms, security consulting firms, researchers, and so on and so forth. And TE providers, such as Intel, AMD, and other hardware vendors which have TE capabilities. Then, the proofs provided by trusted parties can also be trusted, and the reference measurements endorsed by the third-party auditors can also be trusted. The runtime measurements generated by TE providers will also be trusted. Finally, the verification process is very trivial by comparing reference measurements with runtime measurements. Therefore, the verification result can be trusted by public individuals by establishing this kind of chain of trust. Until now, we only discussed the scenario of the transparency for algorithm, or more accurately, software. We can also apply this solution for providing transparency of AI/ML models. Machine learning models, for example, neural networks, is a kind of algorithm compiled from data and other algorithm. Similarly, transparency of machine learning models or machine learning pipelines are also important. Recently, companies and organizations published several principles of trustworthy and responsible AI. Transparency is one of the keywords. Therefore, similar question as we discussed previously. Where is a model come from? How about the integrity of the building and the training pipeline? With trusted computing based solution, hardware endorsed auditable and verifiable proof for machine learning models can bring more transparency to the public, and finally contributing to the trustworthy and responsible AI. Lastly, one thing I like to call out, bringing trust execution environments into more products needs collaborative efforts. For example, establish TE infrastructure and software stack to support large-scale deployment in production. Bring TE to more peripherals like AI accelerators, as well as building remote testing ecosystem with a complete chain of trust that can be verified by public individuals. And we also need to increase awareness of the technology and explore the value propositions in different use cases and bridge gaps of regulatory compliance implications and the technical guarantees of trust execution environment. So recently, we have announced that TikTok becomes the premier member of Linux Foundation Confidential Computing Consortium. For us, we will get more involved in the community and drive innovations towards a more secure and trustworthy future. Thanks. That's all about this talk. Thank you so much.